In this session, we shall discuss the second application of differentiation, that is maxima and minima of a function. Maxima and minima of a function. So let y is equal to f of x be a continuous function. What is meaning of continuous function? The continuous function is 1. For every value of x, there must be a particular value of y. Such functions are called as continuous function. Assume that this is the graph obtained for the function y is equal to f of x. Assume that this is a curve or graph which is obtained for the function y is equal to f of x. This is x values, these are the y values. See this graph, this is the peak, right? This value, this is what? Y along y axis. This is called y maxima. This is the ultimate value of the function which is obtained for x is equal to a. At a particular value of x, y has a maximum value. If I take the values on either side of a, if I take less than a, so you will get minimum less value for this maxima. If I take more than a, this will comes here, again it will be less than this y maxima. Therefore, this will be the ultimate value or maximum value. So at x is equal to a, the function y is equal to f of x as maxima. And see this is the lowest value in the curve. This is said to be y minima. This y minima is at particular value of x. This is called x is equal to b, right? For any function, for any continuous function, there will be a maximum value and minimum value. The maximum value will be obtained at a particular value of x, say a, and minimum value will be obtained for a given function at a particular value of x, that is equal to b, right? So y has maxima at x is equal to a. Y has minima at x is equal to b. To get maxima and minima of a function, we should follow certain procedure. The steps involved to get maximum value and minimum value. These are the steps we have to follow. Steps to get maxima or minima. First step for a given function y, differentiate, get dy by dx, get dy by dx for a given function. Second one, for maxima or minima, either you get maxima or minima, take dy by dx is equal to 0. Either you calculate maxima or minima, you take dy by dx is equal to 0. Then solve for x. Solve for x after taking dy by dx is equal to 0. We get x is equal to a or x is equal to ab, a comma b, etc. Third point, get d square y by dx square. Third point is get d square y by dx square. Fourth point is very important. In d square y by dx square, if the values of x and x is equal to a, x is equal to b are substituted separately, you may get negative value or positive value. If you get negative value, that indicates function as maximum at particular value of x. See this. If d square y by dx square is negative at x is equal to a, x is equal to a, that is function as maxima, function as maxima. Therefore, y maxima is equal to y at x is equal to a. Suppose if d square y by dx square, if d square y by dx square is positive at x is equal to a, it means what? The function has minima. The function has minima at x is equal to a. Therefore, y minima is equal to y at x is equal to a. The value of x, that is a, should be substituted in the given y. So that gives you maximum value and minimum value. For x is equal to a, if you get d square y by dx square negative, definitely for x is equal to b, d square y by dx square will be positive. For a, if you get negative, for b you will get positive, right? If it is negative, what is that negative? D square y by dx square is negative at x is equal to a. What is a? It is obtained by solving derivative. By solving the derivative, dy by dx is equal to 0. So this is the procedure we have to follow to get dy by dx, right? You observe this graph, as we increase the value of x, the x is increasing. See, x is increasing. As the x increases, y also increases, right? So this portion we may call it as increasing function. For increasing function, definitely dy by dx is always positive. Further, you see this from here a to b, as x is increasing, but y is what? It is decreasing. X is increasing, y is decreasing. That portion is said to be decreasing function. Decreasing means y decreases against to the increase in x. Increase and decreasing function. For increasing function, y increases by the increase of what? X, by the increase of x. For decreasing function, y decreases by x increasing. So just remember it as increasing and decreasing function. For increasing function, dy by dx is always greater than 0, positive. For decreasing function, dy by dx is less than 0, that is negative. Okay, so that is not so important. Getting maxima and minima of a function is important. Okay, just remember the steps to get maxima and minima of a function. What are the steps we have to remember? The first step is find the dy by dx. Second step is take dy by dx is equal to 0. Either you are going to calculate maximum value or minimum value, right? After solving it, definitely you will get x values. You may get only one value, say it is a. Suppose if you get more than one, you can take them as x is equal to a, b, c, etc. Third point is get d square y by dx square. Fourth point is important. Substitute x value in d square y by dx square. If you get negative, that indicates function as maxima. How to get maximum value? Just substitute the value of x in y, right? See this. Find maxima and minima of a function. Maxima and minima of a function. 2x cube minus 3x square minus 36x plus 10. Let us take a function 2x cube minus 3x square minus 36x plus 10. Okay. Take this as y. The given function is considered as y. What is the first step? First step is getting dy by dx. Differentiate it with respect to differentiate y with respect to what? X. We get dy by dx. That is equal to 2 into 3, 6x square. 2 into differentiation of x cube is 3x square. So 2 into 3 is 6x square minus 3 into differentiation of x square is 2x. So 2 into 3, 6x minus 36 into 1 plus 0. So it is equal to 6x square minus 6x minus 36. Okay, this is what? This is the derivative. First step is over. What is second step? Either you calculate maxima or minima. For maxima or minima, take dy by dx is equal to 0. Therefore, 6x square minus 6x minus 36 is equal to 0. What to do? We have to factorize it, correct? It is a quadratic equation. We need to factorize it. See, observe this equation, quadratic equation. So all the terms are divisible by 6. You can divide with 6. It becomes x square minus x minus 6 is equal to 0. Factorize this. How to factorize? This is middle term, which is replaced by two terms. Their sum or difference should be equal to minus x. Their product should be equal to product of first and last term. See, in place of minus x, we need to replace two terms. Okay, their sum or difference should be minus x. Their product should be minus 6x square. What is minus 6x square? It is product of first and last term. First and last term. What is this? This is the middle term. Then get the factors of this. 6 into 1 is equal to what? 6. 3 into 2 is equal to 6. Which combination verifies here? If I take 6 and 1, add these two, you will get 7. But we should get minus 1. If subtract it, you will get 5. This should be 1. Therefore, this will not be useful. Take this. Adding this 5. We don't have 5 here. Take subtraction. 3 minus 2 is 1. Again, we are getting 1. Okay, we can use this. Correct? 3x, 2x. Adjust the symbol. So here we should get minus, means subtracting between these two. We are getting this. While subtracting, the bigger number should have same sign of this. What is this? Minus. So bigger number should be negative. And other one is positive. When we have opposite sign, then only we are going to subtract. Correct? So minus 3x plus 2x. Minus 3x plus 2x is minus x. Minus into plus minus 3 2s are 6. X into x is x square. Okay. Now it is x square minus 3x plus 2x minus 6 is equal to 0. Just we have replaced the middle term by two terms. In these two terms, what is common? X minus 3 plus here. If I take something common, definitely you should get same factor, x minus 3. Then what I should take? 2. If I take 2, it becomes x minus 3 is equal to 0. In these two terms, again x minus 3 are common. Correct? Take x minus 3 is common. What is remaining? X plus 2. X plus 2 is equal to 0. From these two factors, get the value of x. That is x minus 3 is equal to 0 or x plus 2 is equal to 0 or x is equal to what? 3 plus 3. X is equal to what? Minus 2. We got two values of x. One is what? 3. Other one is what? Minus 2. Second step is over. What we did? First we got dy by dx. Second stage, we took dy by dx is equal to 0 and it is solved for x values. We got two values of x. What is third stage? Third step is to get the d square y by dx square. Differentiate dy by dx again with respect to x. Therefore, d square y divided by dx square is equal to c d by dx of what? Dy by dx. Correct? D square y by dx square means dy by dx of dy by dx. Which is dy by dx? 6x square minus 6x minus 36. So after differentiating, we get 6 into 2, 12x. Minus 6 into 1 is 6 minus 0. That is 12x minus 6 is the second order derivative. D square y by dx square is 12x minus 6. We finished the third step. Correct? Then go for fourth step. The fourth step is what? The values of x, that is 3 minus 2, are substituted in d square y by dx square separately. At x is equal to 3, at x is equal to, first value is 3, d square y by dx square becomes what? D square y by dx square. What is d square y by dx square? 12x minus 6. That is 12 into x is 3 minus 6. 12 into 3, 36 minus 6, which is equal to what? 30. This value is not important. Whose sign is important? What is it? It is a positive. D square y by dx square is positive at x is equal to 3. Correct? So this indicates, therefore, the function has minimum value. Correct? Minima at x is equal to 3. Correct? The function has minima at x is equal to 3. Now to get minimum value. So minimum value, minima is equal to y at x is equal to 3. By substituting x value as 3 in y, you will get minimum value. Okay. Therefore, y minima is equal to 2 into 3 cube minus 3 into 2 square minus 36 into 3 plus 10, which is equal to 3 square is what? 3 3s are 9, 9 into 3, 27. 27 into 2, 54. 3 square is 9, 9 into 3, 27. Minus 36 into 3, 3 6 are 18. 1 carries, 3 3s are 9, plus 1, 10. 108 plus 10. That is equal to, add all the positive values. 54 plus 10, 64. Minus 27, 108. Those are negative numbers, add them. 135. 8 plus 7, 15. I've written 5. 1 carries. 1 plus 0 plus 2. It is 3, 1. 135. That is equal to 64 minus 135. It is minus of 5 minus 4 is 1. 3. 13 minus 6 is 7. So minus 71, which is what? Which is minimum. Which is minima. Right? Then, so next stage is what? At x is equal to minus 2. At x is equal to minus 2. Get d square y by dx square. D square y by dx square. What is d square y by dx square? It is 12x minus 6. 12 into minus 2 minus 6. That is equal to minus 24 minus 6. How much? It is minus 30. What is it? It is a negative value, less than 0, less than 0. So this indicates that if d square y by dx square is negative at a particular value of x, it indicates that the function has maxima at x is equal to what? Minus 2. How you will get maxima? Y maxima is equal to y at x is equal to minus 2. That is equal to, put x value minus 2 in y, that is 2 into x cube minus 2 cube minus 3 into x square minus 2 square minus 36 into minus 2 plus 10. I replaced all the x values by minus 2. That is equal to 2 into minus 2 minus 2 minus into minus plus plus into minus 2 cube is 8 minus 3 into minus 2 square is plus 4 minus into minus plus 36 into 2 72 6 2s are 12 1 carries 3 2s are 6 plus 1 7 plus 10. That is equal to minus 16 minus 4 3s are 12 plus these are the positive numbers. I can write 82. 60, 16, 12 both are negative. It becomes what? Minus 38 plus 82, which is equal to. So if I take difference, the answer will be the bigger number side. Okay, the bigger number is 82. Positive. We will get positive. 2, 12. 12 minus 8 is 4. Okay. 7. 7 minus 3 is 4. Right? Which is what? This is maximum. It is the maximum. Okay. We followed all the steps. Finally, we got maximum value as well as minimum value. This is the procedure to get maxima and minima of a function. Right? For any given function, to get maxima and minima, you need to follow the same procedure. Okay. Find the maxima of x e to the power of minus x. They will ask you only maximum value. Take given function as y. Y is equal to what? X e to the power of minus x. What is first step? Getting dy by dx. Differentiate it. Dy by dx is, how to differentiate this? It is x into e power minus x. Use product rule. First function into d by dx of second plus second function into d by dx of first. Right? It is equal to x into differentiation of e power x is what? E power x. But here e power minus x is there. Minus x is considered as what? Minus function. It is function. Minus x into differentiation of minus x. It is 1 plus e power minus x into differentiation of x is 1. Now, if I take e power minus x is common, what I will get? Minus x plus 1, right? I will take 1 minus x. This is dy by dx. Next step is what? For maxima, I should take dy by dx is equal to 0. Correct? What is dy by dx? It is minus e power x into 1 minus x is equal to 0. Or 1 minus x is equal to 0 by e power minus x, which is equal to 0. Or 1 is equal to x. 1 is equal to x. So dy by dx is a linear equation. The degree of x is 1. Hence, we get only one value of x. Then, We need to get d square y by dx square. Differentiate dy by dx with respect to x. See, d square y divided by dx square is equal to d by dx of what? D by dx of dy by dx. What is dy by dx? D by dx of dy by dx is what? E to the power of minus x into 1 minus x. How to differentiate this? Again, it is product of two factors, e power minus x and 1 minus x. Use product rule, u into v. E power minus x into d by dx of what? 1 minus x plus 1 minus x into 1 minus x into d by dx of e power minus x. Right? E power minus x will be retained as it is. Differentiation of bracket. Differentiation of 1 is 0. Differentiation of x is what? Differentiation of 1 is 0 minus differentiation of x. It is 1 plus. Keep 1 plus x, 1 minus x as it is. Then differentiate e power minus x. That is e power minus x into d by dx of minus x, that is minus 1. It become minus e power minus x, right? Plus into minus minus e power minus x into 1 minus x. Or if I take minus e power or e power minus x common, you will have minus 1, right? Minus of 1 minus x. That is e power minus x into minus 1 plus x. It become what? E power minus x into minus 2 plus x. This is what? D square y by dx square. Let us cross check. If I substitute x is equal to 1, will you get d square y by dx square? Negative. If I get negative, then only I can say the function as maxima, right? At x is equal to 1, d square y by dx square is equal to e power minus 1 minus 2 plus x is what? 1. That is equal to e power minus 1 into minus 1. It becomes what? Minus e power minus 1. Otherwise, it is minus of 1 by e. It is negative, correct? We got negative minus because e is equal to what? Exponential value. Its value is around 2.71. E value is around 2.71. So 1 by 2.71 minus. So you will get negative only. Therefore, the function has maxima at x is equal to 1. Therefore, y maxima is equal to y at x is equal to 1. That is equal to 1 into e power minus 1 or e power minus 1 or 1 by e. It is maxima of a function. What is the function? X into e power minus x. Okay. Find the minimum value of x square minus 4x plus 3. What is function? Function is x square minus 4x plus 3. Y is equal to x square minus 4x plus 3. What is the first step we need to follow? We have to get dy by dx. Differentiate this. Dy by dx is 2x minus 4 into 1 plus 0. That is 2x minus 4. For maxima or minima, we should take dy by dx is equal to 0. Correct? Maxima or minima, dy by dx is equal to 0. That means 2x minus 4 is equal to 0 or 2x is equal to 4, x is equal to 4 by 2 is 2 only. We got x value only 1, right? Next, what is third step? Getting dy by dx. Differentiate dy by dx again with respect to x, right? That is d square y by dx square is equal to d by dx of dy by dx. What is dy by dx? See, d by dx of dy by dx. What is dy by dx? It is 2x minus 4. That is equal to 2 into 1 minus 0, 2. So here we got d square y by dx square directly the positive value. Okay. So here we got d square y by dx square is positive without substituting x. So that also indicates that the function as minima. Therefore, y minima is equal to y at x is equal to 2, right? We got x value 2. Substitute in y. What is y? X square, that is 2 square, minus 4 into 2 plus 3. 2 square is 4, minus 4 into 2, 8 plus 3. 4 plus 3, 7 minus 8. That is equal to minus 1. What it is? It is minima of function. It is minima of function. You got the procedure to get maxima and minima of a function. So just follow these steps. Definitely you will get maxima and minima of any given function. Okay. Next, let us go to the next application. It is maxima and rate measure. After maxima and minima, let us go to the rate measure. Third application, it is rate measure. Very important. This application, because every day we come across in our daily life. Rate measure. What is rate? Where this word used? To buy a quantity. Suppose I want to buy pen. I want to buy a pen. I should give money, right? As the number of pen varies, 2, 3, 4, 5, the money also varies. Correct? Here we observe that variation of the quantity pen, there will be a variation of money. And that means we are comparing the quantity of pen with money. Like that in our daily market. In daily market, we buy the things. We buy the things with respect to what? Money. The quantity of things varies with money. That is variation of one quantity. Variation of one quantity with respect to another. That is said to be rate measure. What is rate measure? It is just variation of one quantity with respect to the another quantity. That is said to be rate measure. But in the nature, many quantities are varying with respect to time. Varying with respect to time. For example, if I take moving car, the distance of the car varies with respect to time. The distance covered by a car is always varies with time. If I take a plant, the plant growth, the height, growth means height. The height of the plant always varies with time. As the time lapses, the height of the plant always increases. Right? So there is a water tank. We pump the water into the tank. The level of water always increases. The quantity of water collected in the tank varies with respect to time, right? The height varies with respect to time. If the same thing, there is a tank, we are not pumping into that tank, but we are taking water from that tank. The level of water decreases. There we can observe that the rate of change of height with respect to time. You take a calm water surface. There is a calm water surface. If I touch the water, disturbance. It is a wave. How it moves? It moves in the form of circular rings. They are said to be waves. As we observe that, as the time lapses, the radius of the wave increases as well as the area of the wave also increases. We can observe both the variations of radius as well as area. You take a spherical balloon. If air is blown continuously, what happens? The balloon or the bladder, if it is in spherical shape, it will increases its volume. As volume increases, the radius also increases. The radius and volume both are varying with respect to time. So such observations we can make here, right? So in dy by dx, in differentiation, we use always dy by dx. Dy by dx means what? It is rate of change of y with respect to x. Variation of y, otherwise it is said to be variation of y with respect to x. X varies with respect to the y varies with respect to x, right? This is the brief introduction about rate measure. In the nature, we use this rate measure to calculate even profit of a business. Suppose a business is going on in a particular equation. In that also we can get the profit of that business also. Okay. A car is traveling. According to the equation, S is equal to f of t. A car is traveling according to the equation S is equal to f of t. It indicates what? The distance covered by a car is S in a time t. S is equal to f of t means the distance covered by a car is S in a time t. Okay. If it is differentiated, see the rate of change of distance or displacement is what? Is velocity. Correct? The rate of change of distance or displacement is velocity. Then velocity is equal to ds divided by dt. Variation of distance with respect to time. This gives you velocity of a body at any instant of time t. At the same time, the rate of change of velocity gives you acceleration. Correct? It gives you acceleration. That is, acceleration is nothing but rate of change of velocity, dv by dt. Otherwise, we can say that d square s divided by dt square. If the car is traveling according to a law or equation S is equal to f of t, then if you differentiate it with respect to time, you will get velocity. If the velocity is differentiated again, you will get acceleration. Okay. Take a circle, area of circle of radius r. Area of circle is what? Area of circle is A if the radius is r. Then if I take area is equal to pi r square, correct? Differentiate it. I can get the variation of area as well as its radius with the time, with respect to time, right? Differentiate with respect to time. You get dA by dt is equal to pi into r square differentiation 2r into dr by dt. dA by dt is equal to what? Pi into 2r into dr by dt. So this dA by dt is said to be rate of change of area. Rate of change of area. dr by dt always indicates that rate of change of radius. Rate of change of radius, right? Like that we can have the variations of other quantity also. Suppose if I take area of square, if the square is having its sides L, then area of square is what? L square. If I differentiate it, we get dA by dt is equal to, for L, it is 2L into dL by dt. dL by dt is what? It is rate of change of length. It is rate of change of each side. It is rate of change of area. Okay. Area of equilateral triangle. Equilateral triangle. So what is equilateral triangle? All sides are same. All sides are same. This is L, this is L, this is L. Area of equilateral triangle is 4 root 3 divided by 4 into L square. If I take sides as L, it will become root 3 by 4 L square. If I take side as A, it will become root 3 by 4 A square. After differentiating with respect to time, I will get dI by dt is equal to root 3 by 4. For L square, it is 2L into dL by dt. Right? Area of rectangle. Area of rectangle. What is rectangle? It will have its length L, breadth B. What is area of rectangle? Length into breadth. Product of length and breadth. If I differentiate it, I will get dA by dt is equal to L into dB by dt plus B into dL by dt. I should use product rule. Why? Because both length and breadth are variable, which are in product. dL by dt is rate of change of length. dB by dt, it is rate of change of breadth. dA by dt, it is rate of change of area. Okay. Volume of cube. If I take a cube, so cube is having same height, same length, same width, right? Length into breadth into height, all are same. Therefore, volume of cube is equal to L cube. Length is equal to breadth is equal to height. Differentiating, we get dB by dt is equal to 3L square into dL divided by dt. dB by dt is what? It is said to be rate of change. Rate of change of volume. dL by dt, rate of change of each side. Right? Volume of sphere. Volume of sphere. As we know that volume is equal to 4 by 3 pi r cube. Volume of sphere is what? V is equal to 4 by 3 pi r cube. Differentiate it. dV by dt is equal to 4 by 3 pi r cube. Differentiation of r cube is what? 3r square. 3r square into dr by dt. Here also dr by dt is rate of change of radius. dv by dt is rate of change of volume. Next, surface area of sphere. Surface area of sphere. Surface area of sphere. S is equal to 4 pi r square. So it is remembered. See, after differentiating volume 4 by 3 pi into 3r square dr by dt. After cancelling 3, what is remaining? 4 pi r square into dr by dt. Just leave it. 4 pi 3. Sorry, 4 pi r square will be the surface area. Right? On differentiating, I get ds by dt is equal to 4 pi r square 2r into dr by dt. 2r into dr by dt. That is rate of change of surface area and the rate of change of radius. Like that, for any variations, you can use this differentiation to find the variation of one quantity with respect to another quantity, right? Please remember, if any body is traveling according to some equation, S is equal to f of t, it means distance covered by a body is s unit in a time t unit. If it is differentiated, you will get instantaneous velocity, that is ds by dt. After differentiating this velocity, you will get instantaneous acceleration. So instantaneous acceleration is at a particular given time, you will get certain value of acceleration. That is instantaneous acceleration, right? How the problem will be given in these variations? Suppose if I take area of circle, they will give you rate of change of area along with the radius. You should calculate dr by dt. Otherwise, if they give dr by dt and r, you should calculate dA by dt. Right? This is very simple. So S is equal to f of t is what? Distance, right? It is distance. Then what is velocity? ds by dt. What is acceleration? It is d square s divided by dt square. Area of circle, A is equal to pi r square. Area of square, A is equal to L square. Area of equilateral triangle, that is root 3 divided by 4 L square. Area of rectangle, that is A is equal to length into breadth. Volume of cube, V is equal to L cube. L is length of each side. Volume of sphere, V is equal to 4 by 3 pi r cube. Surface area of sphere, that is what? S is equal to 4 pi r square. If I want to take circumference of circle, that is what? C is equal to 2 pi r. Right? So based on that, let us work out now two examples. A body is traveling. A body is traveling according to the equation. S is equal to t cube minus 4t square plus 8t minus 3. 4t cube plus 4t square plus 8t minus 3. Find velocity and acceleration when t is equal to 3 seconds or 3 units of time. They have given s. S is what? Distance covered by a body in a given time t. So how you will get velocity? By differentiating s, you will get velocity. After differentiating velocity, you will get acceleration. Okay. S is equal to t cube plus 4t square plus 8t minus 3. Differentiate it. Differentiate with respect to t. We get ds by dt. That is said to be what? Velocity. Right? Velocity is rate of change of distance. 3t square plus 4 into 2, 8t plus 8 into t. For differentiation of t is 1. For 3 it is 0. 3t square plus 8t plus 8. This is velocity. Again differentiate this. We get d square s divided by dt square, that is equal to, for t square is similar to x square. Differentiation of x square is 2x. 3 into 2 6t plus 8 into 1 plus 0, that is 6t plus 8. We got instantaneous velocity and acceleration. But the question is, we need to find out velocity and acceleration after t is equal to 3. So velocity after t is equal to 3 is velocity is equal to, in velocity substitute t is equal to 3. 3 into, what is t? T is 3 square plus 8 into t. T is what? 3 plus 8. 3 square 9. 9 into 3 27. 8 3s are 24 plus 8. Add them. 20 plus 20 40. 47 51 59. Right? 59 units. Okay. Acceleration after t is equal to 3. Then acceleration is equal to, what is acceleration? It is 60 plus 8. 6 into 3 plus 8. 6 3s are 18 plus 8. It is equal to 26 units. So this is the way of getting velocity and acceleration after a given particular time, right? Just differentiate it, you will get velocity. Just differentiate the velocity, you will get acceleration. Substitute the value of t given, right? A particle is moving according to the law. S is equal to 2t cube minus 6t square plus 10t minus 3. 2t cube minus 6t square plus 10t minus 3. Find number 1, velocity after 2 seconds. Number 2, acceleration when t is equal to 3 seconds. Number 3, initial velocity. Number 4, when the acceleration vanish. When the acceleration vanish. Fifth point, velocity at the time of acceleration is 0. So like that, they will ask you different questions. To all these questions, first we need differentiation of S and a differentiation of ds by dt. Correct? You take S. What is S? S is equal to 2t cube minus 6t square plus 10t minus 3. Differentiate with respect to t. You get ds by dt, which is said to be velocity. T cube 3t square, that is 2 into 3, 6t square, minus what is 6? 6 into t square is what? 12t. 12t, correct? 6 into 2, 12t, plus 10 minus 0. Okay, just leave this minus. This is what? Velocity. Again, differentiate this velocity with respect to t. What you will get? You will get d square s divided by dt square is equal to acceleration. What is acceleration? 6 into 2, 12t, minus 12 into 1 plus 0. That is 12t minus 12. This is acceleration. We got the velocity, acceleration, right? Now calculate individually. First one is what? Velocity after 2 seconds. For first velocity after 2 seconds. It means put t is equal to 2 in velocity. Put t is equal to 2 in velocity. Which is velocity? Velocity is 6t square minus 12t plus 10. Therefore, velocity is equal to 6 into 2 square minus 12 into 2 plus 10. That is equal to 2 square is 4. 4 into 6, 24. Minus 12 into 2, 24 plus 10. Minus 24 plus 24 cancel. So velocity is equal to what? 10 units. If the distance is mentioned in meter, then the velocity becomes meter per second. Second part. What is second part? Acceleration. Acceleration when t is equal to 3 seconds. Correct? Put t is equal to 3 in acceleration. Therefore, acceleration is equal to, what is acceleration? Acceleration is 12t minus 12. 12 into 3 minus 12. 12 into 3, 36 minus 12, which is equal to 24 units. Third one. What is third one? Initial velocity. Initial velocity means the velocity at the beginning. At the beginning means, what is time at the beginning? It is equal to 0. Don't treat initial velocity means velocity is 0. No. At the initial velocity, the time will become 0. Time is yet to start. Therefore, for initial velocity, we have to take t is equal to 0 in velocity. Therefore, initial velocity is equal to, put t is equal to 0 in velocity. That is 6 into 0 square minus 12 into 0 plus 10. That is equal to 10 units. If that's initial velocity, you first get ds by dt, then take t is equal to 0. What is fourth one? Fourth one is when the acceleration become vanish. It means a moving body, when it comes to rest, then it means what? Velocity is 0. When the acceleration vanishes, there is no velocity at all. Means there is no change in velocity. If they ask when does the velocity vanish, when does the acceleration vanish, in that case you have to take that particular value 0. Which particular value? If they ask acceleration, then you take acceleration is 0. When the velocity becomes 0 means you take velocity is equal to 0 and calculate the time. So at the time of so and so, the velocity vanish. That is the answer, right? Take acceleration is equal to 0 to get time. So acceleration is 0. What is acceleration? 12t minus 12. That is 12t minus 12 is equal to 0, or 12t is equal to 12. T is equal to 12 by t. 12 by 12 is equal to 1. So at this time, when t is equal to 1, the acceleration becomes 0. When the acceleration becomes 0, what will be the velocity? That is the meaning of last part. Velocity at the time of acceleration. So fifth one is put t is equal to 0 in velocity. It is asked that velocity at the time of acceleration is 0. When the acceleration becomes 0, when t is equal to 1, right? Therefore, velocity is equal to, what is velocity? It is 6 into 1 square minus 12 into 1 plus 10. This is 6 minus 12 plus 10. 16 minus 12 is equal to 4 units. Like that, they will ask you the velocity, acceleration, initial velocity, and that, right? A body is projected vertically up, and it moves according to the equation S is equal to 160t minus 16t square. It moves according to the equation S is equal to 160t minus 16t square. Find the maximum height. The maximum height reached. The maximum height reached by the body. First, understand the question. A body is projected vertically up, means it is traveling in the upward direction according to some equation. Okay, we have to get the maximum height reached by the body. So while traveling in the upward direction, the velocity of the body goes on decreases. Correct? Because of the acceleration due to gravity, the velocity of the body goes on decreases. Finally, at a particular point, velocity becomes 0. Correct? The velocity goes on decreases and finally it becomes 0 at maximum height. So at maximum height, the velocity always 0 of a projected body, right? So to become velocity 0, how long it will take? That we have to find out first. If we get 4 second, 5 second, 10 second to become velocity 0, then we can say that for so much of time the body is traveled. That will become the maximum height. Got it? Every body projected vertically up, its velocity goes on decreases. Finally, it will stop at a particular stage or at a particular height. That will be the maximum height moved by the body projected. Right? At the maximum height, velocity is 0. To become velocity 0, how long it will take? That we have to find out first. That particular time is substituted in S, that gives you the maximum height traveled. Okay, so take S 160t minus 16t square. Differentiate it. ds by dt is equal to 160 into 1 minus 32t. Okay, at maximum height, velocity vanishes. Velocity becomes 0. Therefore, 160 minus 32t is equal to 0. Therefore, 160 is equal to 32t, or t is equal to 160 by 32. So it becomes what? It becomes 16 1 16 2 2 5 So after 5 units of time, the body comes to rest. Therefore, maximum height will become distance traveled. Distance traveled till the velocity becomes 0. Traveled for t is equal to 5 seconds. Therefore, maximum height is equal to S at t is equal to 5. Substitute in S. S is distance traveled, correct? 160 into 5 minus 16 into 5 square. 160 into 5, 650, 30, 3 carries 8, right? 16 into 5 square is 25. So 800. 16 into 25, it is 400. So 400 units of distance is the maximum height reached by the particle. Okay. So these are the problems related to what? Velocity, acceleration, right? Then let us take the variation of radius, area, and other things. The area of a circular plate due to heat is increasing at the rate of 5 centimeters square per second, comma, find the rate of change of its radius when the radius is 10 centimeter. See the question. The body is in circular shape, correct? On heating that circular plate, its area is increasing. At what rate? Its area is increasing at the rate of 5 centimeters square per second. Means dA by dt is what? 5 centimeters square per second. Right? When the area is increasing at this rate, what will be the rate of increase of its radius? Means dr by dt is how much? At the radius r is equal to 10 centimeter. So this is the given data, correct? The area of circle is increasing. At what rate? At the rate of 5 centimeters square per second. During this increase, the area increases, radius also increases, correct? Suppose this will be the area, comes to 5 centimeters square per second. At this stage of radius, what is radius? R is equal to 10. At this point, what is the rate of increase of radius? That we have to calculate, right? First, observe the shape. What is the shape? It is in circular. Therefore, take area of circle. If they have given area, take area. If they are given mentioned volume, take the volume, right? Area of circle, A is equal to pi r square, correct? Differentiating this, we get dA by dt, pi into 2r into dr by dt. Differentiate A with respect to t, not with respect to r, because r is also varying. Radius is also varying, area is also varying. Then what is given? dA by dt is given. How much it is? 5 is equal to pi into 2 into r. What is r? R is also given. We can substitute it. 10 into dr by dt. The questions will be very simple. Listen me carefully. In all these things, from here to here, area of circle, area of square, area of equilateral triangle, rectangle, volume, other things. Three quantities will be there. One is rate of change of area, rate of change of radius or each side, and the radius or side. Okay. Among these three, two will be given. See, these are the three variations. In all these things, three variations will be there. One is volume, other one is radius or length, other one is radius or length. Volume, radius, right? Radius. Among these three, two will be given. If these two are given, we have to calculate this. If these two are given, we have to calculate this. This is commonly given. Radius or length of side is commonly given. Along with if radius is changing, we need to calculate area. Along with radius, if they give area, we need to calculate radius. Very simple. In 2 or 3 steps, we'll get the answer. So 5 divided by 10 into 2, 20. Pi is equal to dr by dt. 5 1 the 5 4 the. Therefore, rate of change of radius is equal to how much? It is 1 by 4 pi centimeter per second. Radius unit is what? Centimeter. Area unit is what? Centimeter square. If it is mentioned centimeter, you check whether this is given in same unit or other unit. If it is given in other unit, you find equal to this. Sometime we need radius, they will be given diameter. With that we have to calculate radius. Sometime we need radius like this, they will be given area. From the area we need to calculate radius, right? Please remember it. This is a simple problem. Okay. Next problem. The radius. I am changing it. If the radius of a circular plate due to it is increasing at the rate of 8 centimeter per minute, I am taking minute time. Find the rate of change of its area. When the diameter is 100, or I take 200 millimeter. The same question. The given parameters are different and the required parameter is different, right? So what is given and what is to be found? Check this. Read the question. The radius of a circular plate due to heat is increasing at the rate of 8 centimeter per minute. Radius is increasing means dr by dt is how much? 8 centimeter per minute. So time is mentioned in minute. Okay. Find the rate of change of area means dA by dt is to be calculated. With what? With the given diameter. Diameter d is equal to 200 mm. See what is diameter? 200 mm. But variation of radius is in what? Millimeter. First convert that millimeter into centimeter. This becomes what? 20 centimeter. Correct? Divided by 10. This is diameter is given. So we need radius. What is radius? D by 2. That is equal to 10 centimeter. Right? Same formula is used. Area of circle. Differentiate it. Differentiate it. We get the same thing. Okay. dA by dt is how much? We have to calculate. Pi into 2 into R is how much? 10 into dr by dt. Dr by dt is given. How much? It is 8. So dA by dt is equal to 8 into 2, 16. 16 into 10, 160. Pi. What is in it? Centimeter square per, not second, minute. Because there in variation of radius it is given in minute. Therefore, we have to write it in minute only. Right? The same way, observe here. For this, they will give you rate of change of area of a square and rate of change of length each side of a square, and L will be given. Among these three, 2 will be given, 1 has to be found in the same way, right? So I will take problems on volume. The volume of a sphere is varying at the rate of 3 centimeter cube per second. Comma, at what rate? At what rate its radius is increasing or varying, increasing when the radius is 2 centimeter. And the radius is 2 centimeter, right? What is the variation? It is volume of a sphere. Take the volume of sphere. What is volume of sphere? Volume of sphere is V is equal to volume of sphere. V is equal to 4 by 3 pi r cube. Differentiate it. On differentiating with respect to t, we get dV by dt. That is 4 by 3 pi per r cube. It is 3 r square into dr by dt. In the question, they have given the volume of a sphere is varying at the rate of, means dV by dt is equal to 3 centimeter square per second. Right? What is asking? What they are asking? At what rate its radius is, means dr by dt is how much? When the radius is 2 centimeter. Here, substitute the given values. dV by dt is how much? 3 is equal to 3 get cancelled. 4 into pi into r is given 2 square into dr by dt is required, that we have to find out. 3 divided by 2 square is 4. 4 into 4 is what? 16 pi is equal to dr by dt. Therefore, dr by dt is equal to 3 divided by 16 pi. Unit is important, centimeter per second. Right? Sometime they will give you like that the volume of a sphere is varying at the rate of 6, or I will take 48 cc, means centimeter cube. At what rate its radius is increasing? When the volume is 288 pi cc. Instead of giving radius, they have given what? Volume. With a particular volume, we have to calculate radius at the value of this, right? First take the given thing. What is given thing? dv by dt. dv by dt is how much? It is 48 cc per second. Correct? We have to calculate rate of change of radius, that is dr by dt has to be calculated. When what is given? Volume is given. Volume is equal to what? 288 by cc. The same procedure we have to follow, right? See, volume of sphere is 4 by 3 pi r cube. Therefore, dv by dt is equal to what? 4 by 3 pi r cube. 3r square into dr by dt. 3 get cancelled. dr by dt is 48. Correct? Is equal to 4 into pi into what is r? So r is not given. R is not given. What is given? V is given. Just take r square as it is and dr by dt. Therefore, dr by dt is equal to 48 divided by 4 pi r square. 4 1 the 4 2 the. It is 12 divided by pi r square. If we substitute r value, then the problem will be completed. So we need r. What is r? R is not given, but volume is given. At this particular volume, there will be a particular radius, right? That radius we have to find first. How? Just write the formula for this. 4 by 3 pi r cube is equal to how much it is? 288 pi. Pi cancel. R cube is equal to 288 into 3 divided by 4. 4 7 is 28, 4 2 is 8. Then r cube is equal to 72 into 3, 3 2 is 6, 7 3 is 21. Therefore, r is equal to how much? Cube root of 216. If I take 2 into 2 into 2, it is 8, right? So 3 into 3 into 3, it is 27. 4 into 4 into 4, 4 4 is 16, 16 4 is 4 into 4, 16 into 4, 64. If I take 5, 5 5 is 25, 25 into 5 is 125. 6 into 6 into 6, 6 6 is 36. 36 into 6, 6 6 is 36. 3 carries, 6 3 is 18. 18 plus 3, 21. Right? So it can be taken as cube root of 6 cube. Cube root and 3 cancel. R is equal to how much? 6. That 6 we have to substitute here. Therefore, dr by dt is equal to 12 divided by pi into 6 square, or 12 divided by 36 pi, or 12 1 is 12 3 is, right? 1 by 3 pi. Unit is centimeter per second. Sometime instead of radius, they will give you the volume, or in case of circular plate, they will give you the area. With that, we have to calculate the required quantity. Okay, so these are some of the problems related to area, volume, and other things. Please work out more number of problems on this circle volume area of square area of rectangle like that. Okay. So with this, I'm going to conclude my today's class. This is the end of third unit, that is applications of differentiation. If you have any doubt, please raise your doubt